I'm Stephen Foskett, the organizer of Tech Field Day, and we are here at Aruba Atmosphere 2015 doing some Tech Field Day roundtable discussions. Let me have the folks around the table introduce themselves, and then I'll introduce the topic of this session.
I'm Keith Parsons. I run a website called wirelesssoundprofessionals.com, and I do Wi-Fi.
George Stefanik. I'm a wireless architect for Houston Methodist Hospital, located in Houston, Texas. I run a blog called MyEdit211.com.
I'm Jake Snyder. I'm a wireless systems engineer. I am on Twitter at jsnyder81, and I blog at transmitfailure.blogspot.com.
I'm Ryan Adsma, at radsma on Twitter. I blog at techevangelist.net, and I'm a co-host of the Whiskey and Wireless Show.
My name is Jennifer Huber. I tweet at Jennifer Lucille, and I blog at jenniferhuber.blogspot.com.
My name is Blake Croney. I'm a wireless solutions architect. You can find me online, blakecroney.com, and also at Blake Croney on Twitter, and I also do the No Strings Attached show.
Yeah, I'm Craig Schnarz. I'm a wireless engineer for a Fortune 10 company, and I blog at wifi-guy.net.
My name is Alex Lewis. I'm not a wireless engineer, but you can find me on Twitter at AlexLewis.
My name is Andrew Von Egge. I'm a mobility architect. I blog at revolutionwifi.net, and my Twitter handle is at revolutionwifi.
Excellent. Thank you very much. So, as all of us know from reading the popular enthusiast press, 802.11 AC is on the way, and it's going to give us what, 10 gig wireless throughput? I mean, it's just amazing. How are you guys getting ready for this amazing flood of bandwidth? You know, from Wave 2 and MyGig and everything. Who wants to tell us about the joy of this? Blake?
I don't use it. I deploy 20 megahertz channels and call it good. I think this is one of those points in the industry where marketing is driving something that is not necessarily going to be relevant in 90% of enterprise installs.
Yeah.
Education's never going to use it. You in the University of Texas.
Valid in the house with the 80 megahertz. You could do that at home to do media streaming from your server to your TV, but I don't see that's going to be huge in the enterprise.
Because it's all about the clients, because you might have the infrastructure for Wave 2, but the clients are going to take a while to come out, and if you don't have the clients to support it, what good is it? And then the realistic, it's like 5G when Broadcom pumped it. Everything, oh, it's going to be wonderful, it's going to be great. Tri-band radio, get 900 megabits. You look at your little icon in your Windows desktop, connected at 1.3 gigabits. No, not really.
I think, Andrew, you've actually made some comments this week, and I've heard other times talking to you at WLPC and stuff, is that look at the design requirements for getting 802.11 AC speeds just even off of Wave 1. How can we realistically get that in a density deployment?
We can't realistically design for a neg 52 dB signal and a 35 to 40 dB SNR. It's just, you know, with modern enterprise requirements, multi-AP deployments, you have to think about co-channel interference. So 160 megahertz, until we get more FCC spectrum, is not relevant.
The only place you'll see that is in a test bed where they're doing throughput
Well,
testing.
and the actual test bed gives you the throughput, but most of the time, it doesn't matter how much you have it loaded up, you're not getting the throughput over the wire anyway.
No.
Right.
So,
Well, I think that's kind of one of the points is that we're hearing in the industry is because wireless is now getting to that desktop-like speeds, gigabit speeds, that we're starting to hear the push that, well, now you need 2 Ethernet ports on an access port, and you need to be able to lag them, you need to be able to have, you know, MGig or whatever's going to come out next for the standards. But realistically, do we actually even need that?
well, that's at the edge. What I think we need to look more at is our switches used to be aggregators on our network. Now our APs are doing the aggregation. And so now a 24-port switch that just had, you know, 2 gig ports up, thinking it was doing aggregator, it's where the choke point is. And I don't think having this little MGig for uplink from an edge switch is what we need.
How many, you know, I mean, it's like you got to look at what the application flow is too. I mean, what do you have on the local LAN? What's the speed of the connection to those servers? Are they going out to the internet? I mean, who's going to have, you know, realistically a 10 gig internet pipe? If you have a 1 gig internet pipe, that's realistic in a very small minority subset of cases today. But then you're trying to push that even across a couple of those APs. I mean, just from a marketing perspective, not real world. I mean, you've got other bottlenecks in the network or other things that just make that impossible. Even if you take aside the whole Airtime reality that everybody's glossing over.
Well,
You keep
right
talking
now,
logically. This is a marketing thing. Logically, we know the math doesn't work. You don't need it.
Yeah.
Whoa.
Microphone.
We don't need microphones either.
It's funny, I was going to say nobody needs it and drop the mic too.
Oh,
Way to go, Keith.
way to go.
You know, the other thing we don't think about is the clients. Do you really think that little device in your pocket has the horsepower to push those kinds of
well,
speeds?
not even that. We have desktops that
battery
are
life.
already connected at 1 gig
And they're
on a
not even
clean
using-
medium,
They're not even using anywhere
and
near
they're
that.
not saturating those links.
No.
We're,
And what's the use case? What application needs those types of speeds?
I was just going to say, is George, in your hospital environment, that's one of the places where I hear from people that say that they need to have more speed, especially in digital imaging and X-ray and MRIs, because everything has moved to digital technology. It's not going on to film anymore. A lot of stuff is digitized, going between servers. Do you even really see huge impacts in your imaging areas?
Yeah, you know, I think I bring a different perspective because I'm actually the customer end, right? Everyone around the table, I think, is more on the consulting and partner side. So, you know, at our hospital, we just have under 4,000 access points, 30,000 clients. So, you know, we have a real feel for what's going on. I think when we start to look at applications like PACS and cardiology imaging, where you're bringing 3D images of hearts, we're literally bringing it to the bedside today over an iPad. It's really advanced technology. It's certainly cutting edge. Before, you know, you couldn't do that. You'd have to wheel a patient into a room, get them in front of the special monitor so they can see those. I think overall there are very niche places, like many things we do in wireless, where there is a specific need. However, overall, I think Wave 2 and even Wave 1 for wireless AC is much more than what we need today. In most cases, if you have a fundamentally sound, good practice, design network, small cells, low power, optimal clients, you know, you can really get away with just 802.11n.
I'd agree.
I think, though, you know, obviously from a marketing perspective and from where we're going from a chip manufacturing perspective, you know, if you want to purchase anything new, it's going to have AC, it's going to be there. I think when we start to talk Wave 2, we present even more challenges of, you know, how do we sniff those packets? How do we, you know, overcome troubleshooting those packets and client issues? So, you know, it's an exciting time, but I think this is one time where I think wireless is way ahead of the need, which is great, But I remember the times going from 802.11 prime, and that was before there was any letters, you know, after the numbers, you know, and struggling. Wow, we need something faster. And then 802.11b came out. Okay, we're there, but then we still need something faster. And then G came out, right? So again, very excited for the opportunity to still be in wireless for Wave 2, but also to do MGig, it's an expensive proposition.
Well, and I think we're in this horrible cycle of marketing, promoting the feeds and speeds and the bandwidth. When you look at why wireless networks fail, it's not because there's not adequate speed, it's because there's inadequate reliability and inadequate user perception and experience of the performance of the network. And so when I look at that, I look at 11AC and 11N even as more reliable signal quality to our clients. And, you know, it's kicking the can down the road and hiding some design flaws with higher bandwidth is what it really is.
Because it's still up to the clients to do all of the roaming and all of that stuff. It's still up to the clients to do whatever they do whenever they decide to do what they do.
I say 11N was a huge milestone in the wireless LAN industry because of MIMO and the signal reliability. 11AC is just an evolution of that, and we talked with Wave 2 now with MU MIMO, and frankly, there's marketing that's, you know, way out in front on that as well. We're not going to see like the 3 to 4x multiplier in throughput because we can talk to multiple clients downstream at once. I mean, realistically, you know, that's like saying, you know, you're going to get the 1.3 gigabits. Well, that's the raw data rate. What's the realistic that we're going to achieve? You might, you know, get 2x multiplier when it starts to work well, but that's all still yet to be seen. So.
Well, and even Wave 1 AC, we've seen a lot of client problems, a lot of driver problems, chipsets that don't perform well.
Well, and like Keith, you know, with your stress test that you were going to do the round 2, maybe you could expand on what you saw there and why you canceled it.
Yeah, I was going to bring that because it's something that George has mentioned, As we move into wave 1 even, I think our complexity has got to a point where we're out of control. And wave 2 is even going to be further out of control. If you look at a client and I wanted to figure out why a client had a certain behavior, I was prepping to do the next level of stress test, and we couldn't get stability because the clients would sometimes, arbitrarily, choose to go 80, 40, 20 rather than drop from 256 QAM to 64 QAM. Well, I would much rather have them drop their modulation and maintain the second or third spatial stream, and yet there's no nerd knobs that'll let me talk to the client and control that behavior. We know that if we can get every client to get on and off the network faster, we can get density. Well, how do I control them getting on and off the network when they walk out of that 256 QAM zone and instead they don't drop to 64, they drop the spatial stream? I don't like that behavior, and yet the behavior is also not consistent. We couldn't repeat the same thing over and over again, and that's pretty difficult when, with wave 1 chips, we can't even predict what the client's going to do, and that was a set of the same clients. When you go inter-client transactions, how that negotiation takes place, it's not documented, and I'm right now saying to Wi-Fi Alliance, get your act together. You should be testing this stuff. This is where it should be happening at the client side when they get tested, not wait for us after the fact to try to figure out what's wrong.
So it's being impacted by like the 802.11r. Like I know Apple supports it now, but it's new, and it's going to take a while to get people on board and people to understand. I mean, it's supposed to be managing from the clients. It's like you said, unrealistic data rates. Like if you see on Windows, I'm connected at 1.3 gigabits. No, you're not. The way I like to explain it is, think of it like your paycheck. Your raw data rate, that's your gross pay. Your transfer rate, that's your net pay. There's taxes. There's stuff like that, you know. You don't get all that money. If you make, 70 grand a year, you don't make 70 grand, you make 40.
Is that what happens when you get the federal government involved in wireless?
Exactly.
All right, we have a comment here from the audience on that note.
My name is Chris Little from Acuvan. I just wanted to get people's opinions. I've had several customers talk to me about future-proofing. And specifically in regards to this question of the next wave of wireless AC, they're like, well, should we be running 2 cables out just to make sure that when the next wave of even faster APs comes along, that we've, covered our bases as such for that?
Well, if you want to future-proof, run Cat6e, Cat7, single-mode fiber, coax, some power. We don't know what's coming.
Yeah, I think ThickNet would be a real good choice too, just in case.
Just build for what we know is coming. Build for realistically. Two cables to an AP isn't bad. Not required.
I've had some bids come back where the cost for that second one was like an extra 85%.
Right, because
the labor. If it comes in at 40, I could see it, but that on nearly double is a tough call.
It depends on what the copper prices are at. All of that. And what their requirements are. How fast does that AP need to be up if the cable goes bad? But how often does the cable go bad? Build for what you need in a worst case situation. Build for what you know is coming. You can't predict technology that nobody's proposed yet.
And what kind of throughput do you actually need? Can you actually get? Can you actually use?
Go into a network management system for any large enterprise network, probably yours included, George. What's the average throughput on an AP?
It's tiny.
A few tens of megabits.
It's tiny.
At most.
It's small.
So are you planning around the peak for
top end?
the peak for that happens maybe from one client for 5 seconds, or are you planning for what you realistically need to support your business or your environment?
And it's probably going to vary based on industry. I mean, Levi Stadium may have very different wired requirements than George's Hospital or my small office building.
Well, and like I throw out to like what Lee Badman says, and it's like, well, some places you get into those really hard environments. I've got one shot to pull a cable. It's thousands of dollars, and I've been in those situations as well with warehousing. It's like, I'm going to pull in, and I'm going to pull in whatever I have to for a decade down the road. I'm okay with spending that money up front because the risk of not doing it is higher than the cost to do it today.
Yeah,
and so there's a lot of trade-offs that go in, and frankly, the driver, in my estimation, is not the wireless performance. It's other drivers that impact that decision.
Well, so let's talk about the MG base T or N base T switching for that 2.5 gig standard. I'm kind of the opinion is when those products start shipping, net new deployments are probably going to put them in, whether they need them or not. And you're going to
pricing.
Well, it's going to depend on pricing, but you're going to do that same thing. You're going to try to future-proof it a little bit, and it's like, well, if I could get 11N AP today and it was 10% cheaper, should I buy that? generally we send our customers down the 11AC path because there's a product life cycle associated with from the day I buy it to the day it goes end of sale and end of support. You know, are you going to buy a 1 gig switch when there's the next thing there? So those are the questions. And for me, it's not a lot of, do I need that throughput? Maybe, you know, 11AX, that switch might still be deployed. And maybe that 2.5 gig standard gives me what I need at that point.
Right. I look at it from a life cycle perspective. If you're looking at replacing your switch and the price point when it's out is comparable or, you know, within reason, sure, go for it. But if you don't have a reason to life cycle the switches otherwise, there's no need to. So I think it's great to develop the standards today. I see it as a very niche use case today, but great to have the standard. And when new lifecycle, you know, replacements come around naturally for a customer, it might make sense.
So I really hope they start to agree too. Having multiple tracks is not a healthy thing.
This is the evolution of every standard, though. There's multiple, you know, proposed. They're in that phase, which tells you it's really early on in the standard. So why would I buy pre-standard equipment unless I really had to at this point?
Mm-hmm. Yeah. Well, and we've got another comment here from the audience.
Hi, my name's Chris Dugash. I'm the network architect at Carleton College. We're a small residential liberal arts college. As an aside, I have a grant from the NSF to build a 10 gig from the desktop to internet to. Nobody is going to be delivering a gig over Wi-Fi. The systems we have to build to stream real data, you can't do it with consumer hardware. But my question was into the life cycle question. I view my institution, I have a building for 100 years. I refresh it every 50 years. My cable plant, maybe 15 to 25. My closets, 7. My Wi-Fi access points, 3 to 4. But what I'm killed by is the consumer cycle. The devices change every 6 to 12 months. So thoughts on preloading the A-Wave 2 standard with the idea that my clients will catch me before my replacement cycle will allow me to catch up with them. We got burned with the iPad. We can't afford to do it again.
The problem with that, so I worked in a liberal arts school also, and every Christmas killed me because the new devices would show up. The problem isn't that you can't support the new standards, it's that the new standards aren't fully baked yet. The enterprise hardware isn't ready, and the drivers are crap.
Well, I have a different take on that. What we've seen at the hospital is that if I have a 802.11g client and I give you an 802.11ac device, typically your habit isn't going to change. No. You're still going to do the same practices you did yesterday. You're still going to do your same email. If you have that server guy that says, oh great, now I could do my images over wireless. No, that doesn't mean that AC is for you. But the characteristics for us, what we've seen is, you know, you're getting transmissions on and off the air quicker from that standpoint.
I think that's the key, is that you are looking at what are the other efficiencies gained besides speed.
Wireless 802.11ac to me is not about speed, it's about airtime fairness.
Exactly.
You know, if I can get a frame on and off the network, and again, it steps back to fundamentals. If we understand how Wi-Fi works, we know understand DCF, distributed coordination function, how one device can talk at a time. If I can get that frame on and off the network faster, that allows legacy clients more time to transmit. So,
and on the whole client side, if I can get those legacy clients out of the environment and get them up to a newer, you know, 5 gigahertz capable client device, awesome.
Yeah,
but I think the problem is that the marketing that we're being presented with is this fear factor that we have to have 2 cables to the AP. We have to be ready for like the top end bandwidth that's possible, instead of the reality of the on and off the airtime is being
the funny part is, it's one marketing story is added to another marketing story, is added another marketing story, and then we put FUD on top of the whole thing to scare you, when the baseline that the clients are actually using, that it doesn't even exist. It's sand on sand on sand.
Yeah. House cards.
The key is to look at what are the vendors doing as enablers. There's a certain vendor out there of access points that by default enables 80 megahertz channel widths on all of their access points. That's not the right decision to do. Everything should be enabled at the
20.
Lowest common denominator.
Well, but you look then, they get into these RFP and bake-offs and they ship the equipment out there, customer turns it on, they don't do anything, and if you're at 20 megahertz and your competitor's at 80 megahertz for the bake-off, which unfortunately is still the case in our network, in our sales cycles in the industry, is people just turn it on out of the box and who performs better, I'm going to buy that one.
No, that's true. I mean, that's the problem in
and so there's fundamentally, different drivers for what manufacturers are responding to than what customers need. And frankly, a lot of that comes back to education in the industry to, you know, how many bad RFPs do we see? How many bad decision-making processes? People make decisions based on the completely wrong criteria for the network, and they're doing a disservice. And the vendors are responding to that. And until, you know, that's not happening anymore.
Well, the vendors are also promoting that behavior by releasing reports every 6 months that show it's all about speed.
So it's Gartner's fault.
Miracom.
Miracom.
Yeah.
So I want to take one more question for the audience. I'm sorry, but we have to run through, so we only have time for one. Who is it?
Yeah, John from Yahoo again. I just keep looking at the physics. The speed gains in AC come from wider channels, better modulation, and the physics state that I cannot use those in my environment with the number of access points I have to put in. It is physically impossible in this time-space continuum for me to get more than a gig out of an AP, and unless the FCC blesses us with more bandwidth, and it has to be coordinated globally, and a lot more bandwidth to make 80 megahertz channels feasible in the enterprise. This is all a very moot point because it's just physically not possible. I might be able to do 160 at home, but I can still already see 20 APs from my living room. So in my enterprise, it's even worse.
So you can keep talking logically again. What's up with that?
Thank you. Thank you.